Good morning, everyone.
Good
morning. It's a privilege to start the second day of the Core Marine Conference with sharing Rise Edge Energy's view on the future energy and shipping markets. For those of you that don't know us, Rise Energy is an independent advisory, research, and business intelligence company. And as the company name is kind of stating, we're looking at energy. So in that we try to cover the entire energy system, meaning oil and gas, hydrogen, geothermal, wind, etc., etc. Since when you want to look at the transition in shipping, you can't do that in isolation. You need to have a view on the future energy mix for the trade flow perspective, but also to get a view on the availability of alternative fuels and what the price of the alternative fuels can be, as they will be important in order to decarbonize the hard-to-abate sectors like shipping. So I will start out with showing how we in Rise Energy is looking at the energy system. So this chart is then describing the entire energy system, where you have the primary energy sources to the, for me, on the left-hand side here, so solar, wind, hydro, bio, nuclear, natural gas, oil, coal, etc. And then this is being moved and put into the where we make the molecules, so the refineries, which is the third column here. And then this is brought, these molecules are then brought into the power plants, which is the fourth column, where you produce all the electrons that you need. That is then transported and put in for the end user segments, which is buildings, transport, and industry. And the future can play out in many different scenarios. We have been looking at everything from a 2.5 degree scenario all the way down to what we see as the most aggressive transition scenario is a 1.4. The Paris Agreement is a 1.5. But since the IMO revised their GHG strategy in July, this aligns quite well with a 1.6 degree scenario. So I will show a slide on that later in the presentation. So this is the current energy system, and it's heavily fossil-based. 85 to 90% of the total energy used over several decades has been fossil fuel, so gas, oil, and coal. The kind of the end state and the goal for the energy transition will be a new energy system that is no longer based on fossil fuels, but is based on renewable electricity. So then you will move from this system over to this system, which is mainly having primary resources as solar, wind, hydro, geothermal, and biomass. And this energy system has zero emissions associated with it, meaning that it's a clean energy system without all the GHG emissions. How long this will take is, of course, a big uncertainty, and that's why we have all the scenarios. But let's switch to the next one here. This is then showing from the 1800s all the way to 2100, the energy mix, the historical one, and the future one, and this is in a 1.6 degree scenario. So quite aggressive transition to renewables. There's still, in 2050, there's still a share of oil and gas in the energy mix, also in the 1.6 degree scenario. But what is important here is that over the last 10 years, 75% of all the investments has gone into fossil energy. If you want to reach a 1.6 degree scenario, the capital allocation needs to be changed quite dramatically. So we need to put 70% into renewable energy to meet this scenario. But renewable energy is already one of the most competitive energy sources that we have. Examples are, for example, the large solar projects in the Middle East, where the levelized cost of electricity can be as low as $13 per megawatt hour, meaning that if you take an electric vehicle and charge it, for example, at the Al Dhafra project in Dubai, you can travel 500 kilometers for only $1.3 US. So just saying something about the competitiveness of solar PVs. Another aspect of this system is that, as we already kind of mentioned, it will be clean, but another thing that is quite important, especially for the shipping markets, is that it will also be a lean energy system. And what do I mean about lean? Here's just two examples. One is to the first picture here is a typical parking space in China with solar panels. This is about 30 tons of infrastructure, solar panels, that can charge the cars here with all the electricity they need. And over a 15-year period, which is basically the life span of a car, then you can replace 40,000 barrels of oil or diesel. Another picture here is an office building not too far from our headquarters in Oslo, where 10 tons of solar panels, around 100 panels, that last for 25 years. This can replace around 8,000 tons of coal that would be needed to make the same electricity that this house or this office building would need. So as you can see, moving over to a clean energy system and using more direct electricity is also lean. So more local energy production. So more local energy production and also a more efficient system. So in the current fossil fuel system, there's a lot of, around 2/3 of the energy goes to heat loss. So for a coal-fired power plant, for example, you put 100% in and then you get 30% out in electricity. So it's a massive heat loss. This will not happen when you have a renewable electricity system. And this obviously will have a big impact on shipping. Not saying that it will happen in 2050, but over time, you will see a big difference in the shipping market because around 40% of the current shipping is energy related. And you won't need all of this transport of oil, gas, coal in the kind of a new system. So obviously this will have a significant impact. And if we look at this 1.6 degree scenario towards 2050, we actually see that in terms of ton miles, you could see almost a 30% reduction for ton miles of energy shipping, which is quite significant. But of course, the transition can take longer than 1.6 in 2050. I mean, there's a lot of hurdles that needs to be overcome, the capacity of electricity grid, energy storage, all the things. But at some point, this will happen. But there's also opportunities in the transition. There will be more ammonia and methanol transport, and will also be new shipping segments, like the transport of CO2. We are seeing quite a lot of influx of projects where you will use, where there's been indications or announcement that they will use ship as transportation. So we have a CCS team that is covering all the CCS projects. They're looking at the capacity, at least the capacity they want to capture. Where are the terminals? Where should the CO2 be stored? And the distance between the terminals to the offshore storage location or onshore storage location. And mapping all of this up, then you get the trade flow on these projects that you can see here. And adding all this up is around 19 million tons per year. If you then assume average vessel size of 25,000 cubic meters, then this will be around 55 vessels by 2030 and more than 80 vessels by 2035. Again, another market that are facing some technology issues, and this can be delayed, but at least based on the kind of the known projects that we have in the pipeline, this is around where we see it. And a lot of it is North Sea focused, and as the technology develops, you can see more long distance routes, Saudi Arabia, Australia, Malaysia, Japan. The alternative fuel backlog, or the backlog, I think was very well covered by Clarkson's yesterday, but just to kind of summarize a little bit, LNG is the most ordered kind of alternative fuel in the order book. Then we are seeing that methanol is increasing as the most popular alternative fuels. Here we have included everything that is both dual fuel and also ready. So just to highlight that in this selection, I think we have around 150 dual fuel methanol vessels in this selection here. Ammonia, it's pretty much only different degrees of readiness to use ammonia. But we kind of see that methanol and ammonia are the two most popular choices. And then if you have an LPG vessel, it makes sense to use LPG. But companies are still kind of hedging for the future. So a lot of these vessels are dual fuel LNG, and then they also are ammonia, methanol ready. So there's a lot of uncertainty what will be the future fuel and the availability. But there are shipping companies that are taking action already. Shipping companies are used to basically global availability of marine gas oil and very low sulfur oil, so you can buy most of it in the spot market. But in order to be able to get alternative fuels, at least now in the upcoming years, it is important that shipping companies are willing to make long-term offtake agreements in order to secure alternative fuels. This is not a complete list, but it's a good selection of the ones that we know about. Most of it is related to methanol, either e-methanol or biomethanol, and Maersk is, as many people know, kind of one of the front runners here with both firm fuel agreements and then partnership, letter of intent, and then some of these are also MOUs. So it's a little bit of a mix. And the whole market for now is to a large extent characterized by non-binding agreements where you don't quite know what the offtake agreement will be in these contracts. But yeah, on the ammonia side, which is much more immature fuel, then maybe we can highlight Höegh Autoliners, which is much closer to kind of a firm fuel agreement with North Ammonia, and they want to use around 5% of their future fuel mix should be e-methanol. So that's more of it's still a partnership, but a much more firm agreement. One thing I also wanted to highlight is that a company like Maersk has also invested directly into fuel producers, C2X. It's not something that you're used to seeing a shipping company do, but it's much more common in other industries. So for hydrogen, you are quite used to seeing that the off-taker also has a stake in the project. So this could be a trend that we also will see on the shipping side, where some of these larger shipping companies also invest in the fuel production and becoming stakeholders. Then this is our kind of take on trying to forecast and give a view on the prices for alternative fuels. I'm going to focus on e-ammonia and e-methanol in this case and comparing it with very low sulfur oil. You can't really buy e-methanol or e-ammonia in the current market, so it's a cost-based model where we try to figure out what the price can be for e-methanol and e-ammonia. There's a lot of assumptions that goes into this forecasting, but what you are seeing here is apples-to-apples comparisons. So we're taking the density into account of these fuels. So if you see the price of ammonia today, you need to multiply it with around 2.2 to kind of get in the fuel oil equivalents, which is what you see here. And now this is a price difference between very low sulfur oil and ammonia and e-methanol is around 4 times the price, more than 4 times the price. But there's many different ways you can look at this. This is without any regulations and incentives, so I can run through some scenarios for you on the next couple of slides. I just want to highlight one thing before we go into that, and that is there's a lot of talk about EU, at least in the EU fuel maritime. So if you use 1 ton of fuel, you emit 3 tons of CO2. And if the ETS price is 100, then it's additional cost of 300 USD on the fuel you're paying. But the main kind of regulation that is in place that will have a big impact on shipping is the Fuel EU Maritime, with the GHG intensity target that you need to meet, and that will get more and more stricter over time, as 80% much more strict towards 2050, and you need to pay the difference between the fuel you're using and the standard if you're not meeting it, and then it's quite a high penalty. So this is the kind of the main regulation that will move towards more using clean fuels in the EU, and then we'll see what the IMO will be doing going forward. But if you take the Fuel EU Maritime into account, so if you're looking at a voyage between 2 European ports and also assuming EU ETS of $100, you see that in 2045, that's when e-ammonia and e-methanol in our projections will be price competitive with LNG and conventional fuel. And the reason why you see this stepwise price increase in LNG and conventional fuel is mainly driven by the Fuel EU Maritime. Then you won't reach the GHG target. You have to pay a high penalty. and it goes up over time. Of course, for LNG here, you can blend in bio-LNG to meet the target and things like this. So there's a lot of things you can do around this to meet the target. But for the kind of pure LNG and conventional fuel, this is kind of how we see the picture. But there's even more that you can add into the model. One thing is there is quite big production incentives now within the EU and also with the IRA in the US. So this slide here is then showing them the maximum support that you can get for hydrogen production on the OPEC side in the EU, which is $4.9 per kilogram of hydrogen, of green hydrogen, which is 1.5 times more than the maximum you can get in the US. And then if you get this maximum EU incentives, then you see that you can basically push forward the price competitiveness quite significantly. E-ammonia is here 2035, e-methanol 2040. So it's like 5 years at least that you can push this forward. And we can run the same scenarios also for the US, but this shows kind of the impact of production incentives for the price of e-fuels. Of course, not all projects will get them the maximum incentives. Our analysis saying that in the EU, around 17,700 tons of green hydrogen will get the benefit from the hydrogen European Hydrogen Bank. So it's not all projects that will get it, but for those that get the maximum, this can be the outcome. We have a tool for this, so if there's someone that are interested in looking at different scenarios and playing around with some of these input parameters, then you can reach out afterwards and I can show you if you're interested. But that was my last slide, so thank you for your time.
Good morning, everyone. I want to thank the organizer for inviting me to share the GCMD mission to decarbonize the maritime sectors today. Okay. So to start off, I think for those who are not familiar with GCMD, I'll just run through a couple of slides so that you know who we are. And I'll also share a bit more in terms of how we see the maritime sectors, how to decarb, and the type of projects that we're doing to share with you how we try to help the sectors. Okay? So for GCMD, our mission is straightforward. We want to help the maritime industry eliminate GHG. And you ask a question like, okay, let's do it. How do we do it? So we do it by a few ways. By shaping standards, because we believe for the maritime sector, standards are important. Otherwise, when there's too many configurations, the ships cannot connect to the correct fuels, to the correct ports, and the correct cargoes. Okay? The other thing is we also do so by deploying emerging solutions, piloting them, financing those projects. And those are very important because when you start to move from TRL 6 to 7, when the project goes into the water, it becomes very expensive and it requires a lot of stakeholders. As later I will share with you a couple of slides to illustrate that the problem is not something that you can solve alone by a single solution provider. You need to solve together. Okay? And we do so by fostering collaboration within the maritime sectors and beyond the maritime sectors. So how do we do that? We add value through pilots and trials. I want to emphasize that for GCMD, we are very focused on pilots and trials. As much as you have seen studies, the studies are done to support that. And it's required that we need to have that domain and technical expertise. We are also a non-profit organization, so we are a neutral convener for the stakeholders. With the funds given to us by our partners, we are able to do agile funding for studies and also co-funding for bigger projects. And in the project that we do, in the construct, we also involve the regulators and policy makers in the very onset. We believe these are the key elements for to have a successful pilot and to move the needles. Now, this is a very busy slide. It gives you a summary of our projects over the next 5 years since our inception in August 2021. I will share more on the first three, which is ammonia bunkering, assurance for drop-in green fuels, and shipboard carbon capture. We do have a latest initiatives on energy-saving technologies to improve fuel efficiency of ships. that is still in the works, and we will share when it is ready. And the bottom row, it shows the various partners that are supporting us. To date, we have 25 partners, spanning the original founding and strategic partners, impact, coalition, and knowledge partners. So you can see that our center partners actually span a very wide spectrum. And this doesn't include the partners that are supporting our projects, which is more than 80. So this slide provides another perspective of how we see a multi-fuel future. I think I've shared by Joe just now that the future has many scenarios, and you will transit to the renewable era. But if you look at now, if you start to dissect the fuels, we're using the distillate, the residue, and LNG, which is the ambient and cryogenic. So 1, 2, and if I want to put fossil LNG, it is not yet there in terms of green. Now, people are starting to use biofuel, the blends, methanol, followed by the green methanol or the blue methanol, you want to put it, and the bio-LNG, followed by then the ammonia from where the hydrogen is from renewable or from carbon capture source, which is blue hydrogen to blue ammonia. And then finally, we have the ammonia, hydrogen as a liquefied form. So we can see that the transition is moving from fossil-derived to biological, and then subsequently renewable-derived sources, accounting for the entire life cycle with many permutations. So that is a challenge that we're talking about here. So this slides actually shares a bit of the findings of our ammonia bunkering city studies. This was done by Lloyd Register together with Sabana Jurong and the Singapore Maritime Academy. So in short, I think we base it on the Singapore scenario as a bunkering hub, and the takeoff will be around mid-2030, about 2 million tons per annum by 2035. We also have identified over 400 operation and locational risks across 4 concept designs and 3 locations in Singapore, and all are considered low and mitigable. And as a result of these studies, we also have the guidebook that we incorporate into the training curriculum for the Singapore Maritime Academy. And the first course was actually conducted in March this year. And the learning, we also have we shared with the Standard Development Organization, domestically and internationally, to help to shape the standard to say, how are you going to go about doing bunkering, ammonia bunkering specific? It's not just as a cargo. And we also been working with the Oil Spill Response Limited, in this case, to develop an emergency response. You must understand that when we carry such a fuel in a huge quantity, you must also be prepared to say, if there's a spill, what happens? So the emergency team in the respective ports must be ready to address that kind of situation. And of course, all this is to help to prepare ports like Singapore for the first ship-to-ship transfer, to help to gain confidence and competency. And that also applies to other ports. So this slide shows the partners involved in this study, which have completed. And you can see there are 22 study partners, which was assembled by GCMD, starting from producer to the storage, to the barge suppliers, barge operator, terminal operator, vessel operators, owner, ship design firm, consultancy firm, and the field quality and testing. It gives you a sense of, to do such a study, we need to involve so many people to get a very holistic view of how we can get the molecules from end to end. And we also have roped in, we have a link where industries can sign up as an industry consultation alignment partner, and there are more than 130. And we also consulted 8 regulatory agencies. So this was what we did for the studies. Okay. Next steps, we will work with industry partners and regulators to continue to move beyond studies to actual pilot. So to do that, we need a regulatory sandbox. We need to really develop the emergency response procedure. It's not just on paper. It needs to be done. Otherwise, we can't do it. And validate the various hookup arrangements, like shore to ship, ship to ship, in port, what happened in Anchorage. And I think Joe also mentioned SIMOPS. These are the things that is very challenging, that we need to really dive into the detail to say, if we do it, and if you're going to do it, what should we do? And That process, I think, will help to build confidence, and we will also refine and update the draft guidelines, which is right now being in the works. So that's the next steps. Next project is about drop-in fuel assurance framework. Now this project started off with a question that in the future, when we have a lot of biofuel blend, which is the first slides I showed of the fuel transition, a lot of the green fuels will not be available in huge quantity. A lot of assets will be current. So you have seen biofuels, maybe bioenergy or biomethanol coming into the picture in limited quantity, in which then you need to, in some cases, need to physically blend it together. Now, how would you know, the ship owners who buy the fuel, that you are getting the green product that you are buying? For example, in HVO and MGO blend, can you tell the molecules of HVO once it's blended beyond the paper? And similarly for other bioproducts. So this project started off building upon what we know today for bunkering: quantity, quality, in addition, abatement. So once you take abatement into question and take life cycle, you need to start to track the fuels from origin all the way to user, which is very important, okay? So how we did the project, we actually constructed in such a way that there's 5 supply chain using used cooking oil, methyl ester, with high sulfur, with low sulfur, B20, B24 in Singapore, also at Singapore Port. So we completed supply chain 1 and 2, you have seen in our press release. Also supply chain 4, which is HVO, MGO at Port Rotterdam, B30. And we are in the process to execute supply chain 3 and also supply chain 5 in this case. CO is crude algae oil. We are exploring that as a combination to look at the future biofuels with greater potentials. So that's the current status of this project. And this is the ecosystems of the partners around it. Some of the stats above. So for these projects, the way we did it was we work with the fuel purchaser, which is the most important, the demand driver, together with enabler, the people, the technologies and the tracers, and engine OEM, and the test labs, which is very important. We need to make sure that whatever fuels that we're doing, in addition to being able to work, you also comply with the quality. So we have long-run degradation tests. With this group on the right, then we engage the upstream supplier in terms of what are the fuels I want to buy under a BAU scenario, but then we put in all the traces, all the various measurements, and various tests to collect the data across the entire supply chain. So this project will be completed next year, so then we will share the reports. Shipboard carbon capture. I think we should say green fuels will not be available. A lot of the fossil will still be around. Even the future fuels will also have a carbon bond like methanol and LNG. So how do we help the world to decarbonize, the maritime sector to decarbonize? Carbon capture is one of the technologies is used by land-based, and the shipping sector is also saying that, can I use this technology too? You know, I'm not going to have enough green molecules, okay? And if I have a lot of fossil, maybe I can do the same as a SOx scrubber. I capture it, then I kind of offload it and manage it accordingly, like utilization or sequestrations. So in these sectors, in this particular project, we try to answer the question on, can this be done on board the ship? Is there sufficient energy? Is there sufficient onboard space? And what are the challenges involved in putting a system for different fuels? For example, let's say it is a high sulfur, you need a SOx scrubber in addition to it. The type of emission coming out determines what kind of technologies and the difficulty of how you capture the CO2 beyond what we know today as, even for green fuels, you need to customize the systems in such a way that it can capture. And the bigger problems will also begin then after you capture. What do you do with that huge amount of liquefied CO2 on board the ships? Do you store it at medium pressure, low pressure, in ISO tank, in Type C tank, for different ships? Where do you put it? And when you reach a port, How do you actually offload at anchorage, at berth? So there are many questions to be answered. And that's not the end. After offload, that's not the end of the problem yet. That molecule, CO2, need to be either properly utilized in the permanent state or sequestered. So if you capture 100 units on ships, you don't actually capture 100 because when you end 90 at the end, that is the amount that you actually sequester and capture. Of course, there are some rules and regulations you can say in terms of custody transfer, but these are things that we need to understand more. So for this particular work stream, we started off with the onboard capture site with the attempt to say, okay, let's try to do this from end to end, starting with the ships. So these projects with Project Remarkable, with OGCI, Stena, and of course various players, various industry partners supporting us. We started off with 3 phases. We start with first phase, which is concept design and feed, which we are wrapping up this year. Okay? So the attempt is to understand if you're going to build such a system on an MR tanker, and we captured at 30% and 100 kg per hour, with the attempt to say it must cross from port to port, how can this be done? So for this project, we have done it based on the generic technologies so that we can share the results as much as possible with the industry when the results is out for phase 1. And then there's a gate review to say, okay, does this make sense? Are we ready to move to the next steps? Can it be installed? If installed, then can we offload? So we are at that stage where we are going through a review to understand, do we want to move to the next steps after we complete phase 1? Okay? We don't wait for this project to finish. Concurrently, April this year, we also awarded a study to Lloyd Register and Arab. We asked the question, okay, assuming I got captured CO2 on the ships, how then should I do the offloading? Simple question, but when we dive into the subject matter, we realize, hey, actually it's not so simple. You know, this is not on the land to a tank to a ship. This is on the ship where a busy port, you got many ships coming, and many small ships go and pick it up and transfer and aggregate to a shore tank. And some instances, the ships are actually doing their cargo offloading, then you need to simultaneously offload the liquefied CO2. And I'm just talking about one form, liquefy. I haven't talked about the carbonate. I haven't talked about the different types of carbon capture technology. So we ask ourselves, in this space, let's say we have this pathway moving forward to the shore utilization. How should the shipping sector best do this? Now, it's an important question because, remember I mentioned standards? Can you imagine there are 1,001 ways of doing this? Then it is impossible for ship owner to say, what solution do I deploy? The ports will say, hey, how are you going to give it to me? So we hope through this study, the shipboard carbon capture provider can unify in terms of what type of storage means should I design in such a way that the port knows that there are 2 or 3 options at maximum that I can receive, and standardize the infrastructure investment in that aspect, including the LCO2 receiving vessels, a bit like the bunkering, but in this case, you take out the CO2. And there's also the question whether it is considered a feedstock or a waste. It matters a lot because it actually determines whether you can offload into that country or that ports, which will enter into the national accounting. So the scope is written below: onboard capture, onboard storage, the concept to safely and accurately offload shipboard CO2. The readiness of the infrastructure is important. It's a network that you need. It's not about I go to point A, then I cannot offload. I go to point B, then I can offload. The consequence is you're going to carry captured CO2 around the world. And that will have its operational constraint and economic penalties in terms of cargo space and cargo weight. Okay? And we also want to understand what is the CapEx and OpEx model for the scenario in this case. If you are capturing at medium pressure or low pressure, how should the receiving infrastructure manage that molecule? And if it is for a particular application like concrete quarrying, greenhouse, or aggregation to a sequestration site, what is the quality of the CO2 that I need? It matters a lot because all this will impact when you start to aggregate and store in bulk and manage that. And more importantly, what are the gaps in terms of custody transfer, competency standard, and regulatory approval? Will the port receive, if it is a waste, will they receive the waste? And it's not just any waste, it's a waste that may potentially increase the CO2 accounting inventory. And of course, then we'll validate that finding with the industries. So again, we take the same approach. We assemble a group of stakeholders to support the consultant for this 9-month study, starting from LCO2, solution provider, port regulators and observer, port and storage terminal, vessel owners and cargo owners, shipyard vessel design, and enablers. So all in all, we have about 27 partners helping us, not including the industry consultation alignment panel, which of course you can go online and click on the link. Then we evaluate whether you can be part of this study. Okay, so right now we are now in the month of October. This study will complete by January or first quarter next year. So we hope to share the results sometime around second quarter next year when we polish up the study. Okay, that's my last slide. Thank you.
Good morning, everyone. I'm Park Jin-seop. I'm working for HD Hyundai Global Service. Today, I'm going to talk about cybersecurity solution of ships development and commercialization status of HD Hyundai Global Service. This is the content of my presentation. I have 6 parts in this presentation. The first 2 parts will be familiar to you, and number 3 and number 4 and number 5 have been discussing between ship owners and shipbuilders and shipping companies. Before I start my presentation, I'd like to give you a brief overview of my organization. Hyundai Global Service has developed its own smart solution. The new build market will require increasingly cyber resilience for newly built ships. And we have been working on system integration, and starting this August, to be exact, August 1st, we have been running this team. Last year, IACS withdrew UR E26 as well as E27. For E27, revision was announced, and the effective date was delayed by 6 months, and E26, its revision will be released by the 4th quarter of this year, and the effective date will be delayed by 6 months, just like E27, and there could be more grace period. For E26, more specifics need to be determined, so we are expecting more revisions. My team is closely working with the cybersecurity team at KR so that we can cope with uncertainties in the future and to deal with the new revisions. As the previous speaker said, we are seeing more and more eco-friendly ships. EXI, EU MRV, and CII, those mandatory requirements have been introduced to the market, and they all require data collection, and transportation onshore to offshore has been also made. It might sound like a distant future, but LEO suppliers will offer and will make ships more accessible. And there are some prerequisites we have to ensure before we open up and usher in the era for autonomous shipping. So cybersecurity is part of our daily life, especially in shipping. I originally planned to introduce you our cybersecurity system. I plan to unbox it in front of you, but due to some constraints made out of IACS, I can't do that as I planned. Let me briefly introduce you UR26. For safe operation of ships, this is about cyber resilience, which is the capability to reduce the occurrence and mitigating the effects of cyber incidents arising from the disruption or impairment of operational technology. Here, OT is the keyword, and if that happens, if disruption or impairment happens, it will cost significantly. Cyber resilience will protect ships. And IXUR 226 requires ships to be equipped with cyber resilience capabilities so that cyber disruption or cyber impairment will not happen. Let me briefly touch upon the cyber resilience and cyber security. Cyber security, this is what you already know, so let me explain cyber resilience first. Cyber resilience is the ability to quickly recover and restore systems, networks, or data from cyber attacks or anomalies. And cybersecurity means protection from hacking, malicious attacks, or unauthorized access to systems and data. And cyber resilience on board, the cyber resilience of a ship ensures the continuity of a ship operations by enhancing the ability to respond and recover from cyber attacks. The cyber resilience includes not only defense against cyber attacks on ships, but also quick response and restoration to normalcy in case a cyber attack succeeds. This is where we stand in terms of cybersecurity preparation. Some shipyards are already prepared for cybersecurity, but there is variance among shipyards and shipping companies and liners. That means E26 and E27 are not clear enough, so they need some clarification, and some ship owners are saying there are overlapping requirements between the two. Let's take some case one. Case one requires application of all cybersecurity measures, but case two requires only part of them. And this criteria has been interpreted differently among shipping liners or ship owners. OCPS can be controlled all at once, including OT equipment. The centralized management can be possible. Document control can be done in a shorter time. And there could be more requirement for security equipment installation because there will be more security zones. So ships need to be prepared for those zones and cybersecurity equipment, and this will raise the bar of cybersecurity. some ships are required to have the overall cybersecurity equipment according to demand from ship owners. So E26 goals may not be achieved. That will make some shipping companies or ships not be able to meet the requirements of international regulations. We do not know what will happen in the future, but at least we need some safety measures in place. Have cyber resilience for some networks and cyber network for overall network. They needs to be decided so that there is no confusion or uncertainties for shipyards and ship owners. Let me tell you the importance of dedicated cybersecurity solutions for ships. Most of the shipping companies are looking at different options of solutions, and there are cheaper options and more affordable options and many different options. But the cybersecurity solution need to be sophisticated, especially because ER26 and E26 and E27 are not clear enough. Interconnection is one of the key important areas. NMS and firewall are the areas where the operator's discretion and judgment is required, and operators, in case of a firewall incident, need to be prepared for effectively and adequately handling the incident. This is one of the most frequently asked questions from ship owners. OTS issue can happen, but sometimes it cannot be identified by NMS. So some operators may be left helpless. So in conclusion, NMS, firewall, and OT, the interconnected monitoring between the three is required. As you can see on the slide, they should be able to go back and forth between the three, but it's not clear, as I repeatedly mentioned. So we are waiting for clarification of UR826 and UR827. CQ that we are developing can handle the overall security system for NMS, OT, and since we are providing controllers for ships, so we are ensuring compatibility, network monitoring, a security solution, and security blocking. Actually, we are testing them for now, and in the future, engine control system and other control system and the terminal of OT, we are going to make all of them part of our cybersecurity solution. This is the summary of Hyundai global service solution. We are testing and verifying the internet working between NMS, firewall, and OT. And with KR, we are working on IACS-URE 27 type approval certification. We are expecting this to be completed by the first half in 2024. We plan to have a team dedicated to ship cybersecurity service, after-sales service, and we will provide a subscription service for malicious mails. To ensure ships' safety, we plan to install remote control tower. With that, I'd like to conclude my presentation.
Good morning, ladies and gentlemen. I am Song Won-ye from KR. First of all, I am thankful for the opportunity to make presentation at Comarine Conference 2023. My presentation is about fire safety for onboard electric vehicles. I would like to briefly explain what we can do on board to prevent the fire accidents. First of all, I will briefly explain about the background, about the problems of possible fire of electric vehicles on board the ship, and I will explain about the applicable IMO regulations, and I will explain about the activities and practices we can implement for fire safety on board the ship. First of all, background information. Electric vehicles are increasing these days. In order to achieve zero carbon initiatives, there are transitions going on in the maritime sector, and the same goes true for electric vehicles sector. The demand and penetration of electric vehicles have constantly increased, and for the future, the extent of increase of electric vehicles will further grow for the future. And the electric vehicles, once they are produced, will have to be transported through ships. Many people say that once you get fire on electric vehicles, you cannot suppress the fire. It takes a huge amount of time to suppress fire of electric vehicles. And PCTCs are carrying thousands of electric vehicles, and if any fire takes place on board PCTC, then a huge problem will be created. Then let us have a look at the safety and the level of risks of fire of electric vehicles. You might have heard a lot from the news and media about the accidents of fire of electric vehicles. But if you compare electric vehicles with other gasoline or diesel vehicles, the probability of fire of electric vehicles is lower compared to that of other conventional vehicles. And when you carry this on PCTC, fire of electric vehicles could take place when the electric vehicles are being charged, or in the process of sudden acceleration or deceleration of electric vehicles, the probability of accident increases. But on PCTC, electric vehicles are fixed in a location, so the possibility of fire is very low. However, still, once the electric vehicles get the fire, then it cannot be easily suppressed, so the risk still exists. And because of the thermal runaway phenomena, if the fire takes place in electric vehicles, the fire will get more severe because of the thermal runaway phenomenon. So many people perceive that electric vehicles have a high risk of fire. And even if you initially suppress the fire of electric vehicles, the fire is likely to be reignited. Recently, there were fire incidents on PCTC in February 2022. The ship actually sank, and in July 2023, the fire took place in PCTC. This ship was towed into port, it didn't sink, and now investigation about the cause of fire is now being done. If you look at these incidents, they say that at first the fire took place because of the electric vehicles, and a few weeks later the media says that there was no problem with the electric vehicles. As you see in the photo, some say that electric vehicles have nothing to do with the fire incident, but some other media reports differently. But in fact, there has not been clear evidence about whether the electric vehicle was the main cause for the fire on PCTC. But regardless of what the fact is, the risk of fire still exists when electric vehicles are loaded on PCTC. So we are trying to discuss how to prevent the fire on PCTC carrying electric vehicles. These are IMO regulations. Under IMDG code, electric vehicles are supposed to be carried on PCTC without special requirements. So, for carrying electric vehicles on PCTC, no special requirement is needed. But considering the risk of fire, IMO is discussing the amendment of the code. First of all, under CCC 8 and 9, discussions are going on regarding the risk of fire of electric vehicles. For example, what kind of measures need to be taken to prevent fire when electric vehicles are carried on PCTC. SOC, the state of charge, is also one of the elements being discussed. They say that the state of charge of the battery should be limited. And the 10th CCC meeting will be held next year, and discussions will continue regarding these topics. Next, what kind of measures and equipment are needed to be established on the vessels to prevent fire? This is also one of the agenda for SSE meeting that will be held next year. And maybe it will be held from March next year. And in that meeting next year, they will discuss what kind of additional systems or equipment are needed to prevent and deal with the fire of electric vehicles on PCTC. But so far, IMO has not yet come up with a clear guidance on what we need to do regarding the possible fire incidents of electric vehicles on PCTC. Even if IMO comes up with a clear guidance, it will take a long time for IMO to officially institutionalize that guideline into its mandatory code. But still, many electric vehicles are being transported on PCTC. So let us have a look at what kind of practices we can do to prevent the fire, to ensure fire safety. First of all, we can limit the battery SOC to a certain level. Because of the thermal runaway phenomena of electric vehicles, fire could take place. The thermal runaway is closely related to the battery state of charge. If you lower the battery state of charge, you can reduce the possibility of thermal runaway. When you carry electric vehicles on PCTC, you have to limit the level of SOC. so that even if fire takes place, you can reduce the damage on the vessel. I met with some PCTC carriers, and they were asking the shippers to limit the SOC of the battery of electric vehicles to prevent incident. Second option is to limit the charging of EVs. In reality, many electric vehicles are loaded on one PCTC, but when they have to offload the electric vehicle from the ship, they need to have those electric vehicles charged, because if the electric vehicles are discharged, then it would be difficult for them to unload the vehicle from the vessel. So if there's a situation where they have no choice but to charge the electric vehicles to a certain level, they have to comply with the safety rules. And if fire takes place in electric vehicles, the fire will grow uncontrollably, so it's important to detect the fire early and take action as soon as possible. So we can install the CCTV to monitor the electric vehicles and see how the fire took place. Additionally, we can use portable thermal imaging camera. So we can use such camera to monitor the electric vehicles and to respond properly to any fire incidents. You can also use this to detect the temperature inside the electric vehicles. You can also use the camera in the process of fire suppression. Regarding the thermal imaging camera, that was a good option. And you can also use the camera along with fire blanket. Fire blanket is often used for responding to the fire incidents of cars that happened on the land. So you can just cover the vehicle with this fire blanket to prevent a further spread of the fire. On the land, you can see fire blanket being used for suppressing fire on the parking lot, for example, or on the road. So we can use fire blanket on PCTC as well. But after the vehicle is covered with fire blanket, you have to check if the fire was properly suppressed, but that's difficult. And if you open the fire blanket when the fire was not fully suppressed, then fire could rather grow further. So you have to use the portable thermal imaging camera along with fire blanket. So after covering the vehicle with the fire blanket, you have to check the temperature inside the car. Next option is to spray water, which is one of the most common methods. In the case of the vessels, there would be many fire extinguishers on board on PCTC. So you can use the fire extinguisher and spray water to suppress the fire. But there's a difference with from the land. If you spray water on the land, the water will naturally just disappear. But if you spray water on the ship, if the water is not properly discharged outside the ship, then it could affect the stability of the ship. If the water sprayed to the vehicle is not discharged but accumulate on the surface of the vessel, then if it is accumulated on the surface and if it causes sloshing, then stability of the ship could be lost. In that case, the ship is likely to sink, for example. So if you have to continuously spray a large volume of water, you have to make sure that the water is properly discharged over the ship or outside the ship. Next, there are various equipment that we can use. The firefighting equipment or tools are not difficult to use. But electric vehicles have different characteristics from general vehicles in terms of the characteristics of the fire. If fire takes place, it will generate a lot of toxic or hazardous gas. So we have to ensure safety of the crew. They have to fight the fire in a safe manner. So we have to make sure that the seafarers or crew are well aware of what they need to do when they respond to the fire incident. They should receive trainings and they have to conduct drills. And conclusion, the maritime transportation of electric vehicles are increasing, and the PCTCs will increasingly transport EVs. If fire takes place, although the probability of fire is low, electric vehicles have a high risk because once it catches fire, it is very difficult to suppress the fire. So we need to discuss additional safety measures. And we have to, for example, reduce the state of charge of the battery. And of course, we need to have the official regulations to be applied to the sector, but it will take a long time for IMO to come up with the official regulation. And as I shared with you during the presentation, there have been several fire incidents on PCTC, so we have to prevent the recurrence of the incidents. In order to ensure safety, we need to take additional measures and implement some practices to reduce the risk of fire, which are not difficult. Thank you very much for your attention.